Good evening.
Good evening, everybody. So, last class we looked at some tools, although we weren't able to look at everything. And I kind of like reviewed the video, what we did, and like I wanted to make like some corrections. Like I remember, like I taught you guys how to create a key store with Starkli, and then someone asked me like, how do you like, can you like inspect the private key or something? And I wasn't like, for some reason we weren't able to inspect it, so I want to like show you guys that first. If you were in the class, just give me a minute. Can you guys see my screen? I guess not. Can you see my screen?
Oh no, we can't see it yet.
Okay. Someone says GM, not good evening. Okay, sorry, GM. Okay, you can see my screen now, I guess.
Yes, I think you can share the slide link in the chat.
Okay. So I've shared it. So if you recall, yes, like the last class, we created a key store, this secret key.json, and like someone asked me like, how can we like look for the private key? So if you guys remember, to create a key store, Starkli signer key store, and I always said we should always try the help command before anything. So in order to inspect the private key, there was actually a command specifically for inspecting private key, but I didn't see that for some reason. The reason we couldn't find it was because we were trying this inspect command that just fetches only the public key, but this inspect private key command can fetch the private key. So let's try it out. Okay, yeah, we need to pass the name of the file. Just secret key.json, if you can remember.
Hello, sir. There is no movement on your screen.
Oh, wow. Okay, give me minutes. Let me unshare and share again. What about now?
Yeah, we can see your screen now.
Okay, I can increase the font. So remember the last class when we created the key store, we're able to like we created the key store secret key.json. So this is the command I was telling you guys about. Key store inspect private key. And as usual, we'll just give it a password, the password that we put for the file. And okay. And we can see the private key is displayed. So if you
So
want,
please increase your fonts.
okay.
We still can't see movement on your screen. I don't know whether it's on my end.
Can any other person see my screen clearly?
Yeah, I think the thing when you get to your terminal, it freezes.
Like freezes. So yeah, this is the command. Like I was telling you guys, there's an inspect command for inspecting the public key. There's an inspect private command for inspecting the private key. I just wanted to just go over that. Then also, like we mentioned scripts, like running scripts with Scarb, but we're not able to run a script. And I was able to find out why we're not able to run a script. So I think we created a file GIDA token. Let's just open it.
Could you make your font a bit bigger?
Yeah, I'll do that.
Yeah.
Can you see it clearly?
Perfect.
Yeah. So remember, I said like to write a script, we have to create like in our scarb.toml, create a script section, and then we'll define our scripts. So, and I said the goal of script is to simplify commands, and the commands don't have to be Scarb commands. It can even be like we're going to look at Starknet's Foundry. We can actually write scripts here actually to simplify commands that are not related to Scarb itself. So, for example, this is scripts that we can call, let's just call it Cairo, I don't know. And let's say it does two things. It runs our Cairo code and then it also tests it. So the mistake we're making was to run a script, we don't just write like Scarb Cairo, for example, like the name of the script. You have to put Scarb run Cairo. So that's why it wasn't working. So let's try that. Okay, I think I need to give it some space. And you can see it's running the commands in the script. It first like it runs the Cairo code, gives us like an output, and then it also like tests the command and tells us like, okay, all the tests passed. Yeah. So I wanted to also show you guys that. Now we can go to what we have for today. There's something that we didn't also look at that is also important for our Starknet Foundry was Katana and Starknet DevNet. We couldn't look at it the last class. So what is Katana and Starknet DevNet? They're kind of the same thing. They serve the same purpose, which is why I said we can download either of them and use them. So they're basically like a development node. Like when we fetch data from the Starknet blockchain last time, we use like an RPC. But we can't always, well, mostly when we're testing, we don't always have to have access to like a test net or the mainnet. We can have access to like a local blockchain, like a local node that just kind of simulates the blockchain and allows us to test our code and like write and like invoke our contracts, read and write and do whatever we want to do. So Starkli and Starknet DevNet, that's what they are. They're basically just development nodes that run on our machines and allow us to basically do whatever we will have done on the blockchain, but test it in a local environment. So like you see here, it allows us to test our programs, right? Like, okay, usually when you are like writing to the Starknet blockchain like we did yesterday, you have to pay gas fee. And like always having to go to a faucet to get gas fees is kind of burdensome. So a development blockchain will allow us to test our this without having to bother about gas or having to bother about creating accounts because all these things are already there for us. So were you guys able to download like Katana or Starknet event yesterday? Any person that was able to download it? Was anybody able to download Katana or Starknet DevNet on their system? Okay. Yes, exactly. Hillary, just like npm run dev, exactly like that. So if you have Katana installed on your system, let's just test it out. Katana. As you can see, version. Oh, let's just try writing Katana on our system if you have it installed. Let's write Katana. And you can see it starts like a blockchain, local blockchain on our system. with pre-funded accounts, a private key, like not just one account, multiple accounts with private key, public key that we can already interact with rather than creating accounts from scratch. And also gives us an RPC endpoint, which is basically localhost for us to connect to that we can now run commands on. So that's Katana. Then Starknet DevNet, if you have it installed, just try the same thing. Just type Starknet DevNet without anything. And basically the same thing. We have a local blockchain with pre-funded ETH and stack tokens, so we don't have to pay gas and accounts, almost like 5 accounts or 10 or so that we can use without having to redeploy accounts all over for every test I want to test. So is that clear? Does that make sense?
Yes, can you have both of them installed, like the Katana and the Starknet at the same time?
No, you can. Like I do have both of them installed, but I'm starting to prefer Starknet DevNet like more to than Katana. They basically do the same thing, just built by different people in the Starknet community, but they kind of serve the same purpose, just like a testnet blockchain for you to just basically a simulated environment for you to try all your Starknet commands. And we're going to use it to deploy our, like when we write a contract, we're going to use this because I think the last time we deployed to the Sepolia testnet, but this time we're going to use this, we're going to test it using Starknet DevNet. So for Katana and Starknet DevNet, like I said, whatever command you're trying on the command line, if you want info on what else you can do, and just try help. And it works for every single command. And then you can see some flags. Like for example, whatever Katana did is basically like the default state. You can tell Katana, for example, now that, okay, I want to give like 3 accounts, for example. Let's say Katana accounts. I want only 3 accounts. Oh, I think I didn't spell it to accounts. And you can see just bootstrap like a local blockchain with 3 accounts. And this same command also works for Starknet DevNet. So we'll do Starknet DevNet help. Now we can see other things we can call accounts also.
Sorry, sir, your screen is not moving now. Am I the only one?
It's moving, so I guess it's
I
you.
think you're the only one.
Exit and join back.
Yeah. So like you can see, you can give your blockchain like an initial balance. You can change the ports that you are listening to and like the gas price. You can just tweak it to whatever you want. And also like why this is important, like when you are testing smart contracts, sometimes you want to like fork the blockchain in a way, like just replicate the blockchain, the actual blockchain, replicate it on your system and be able to like test as if you are actually testing on mainnet. So with Starknet and Starknet DevNet and Katana, you can also like fork the blockchain, mainnet, Sepolia, whatever network, and just like actually see how your contract will be in a real life situation, like kind of replay it basically. And to do that, there should be like for example, you can see this now, there's a fork network, and then you give it a URL. Should we try that? Let's try that. Just test it. And this is very, very useful for like testing, as you can imagine. Let me get my RPC that we used last time. I think it was an alchemy. I've all of a sudden forgotten how to spell alchemy. Yeah. So let's test that out. Let's see if it works. Okay. Starknet, DevNet. Let's just try doing help to see where we got it wrong. So I guess when we're fucking, we actually have to pass in like a block number and all that. I think maybe we'll try this when we are testing our smart contract, just so we can just go into all we have for today. But I just want you to know that you can. There's someone has a question: does Katana require much power to run on my system? No, it does not. Like it's not actually going to like. Okay, so when you're fucking the blockchain, like if that's what you want to do, like you specify like a block number you want to, like let's say you fuck it from like Genesis now to a particular block, and it still kind of connects to like an RPC node, but allows you to like not pay for gas and basically do everything you want to do. So it's still not the real network, but it has like everything that makes the real network. All the rules that guides the Starknet mainnet still has the same rules for you to now test all your contracts. So yeah. So I wanted you guys to know that. So let's go into what we have for today. Today we are going to be looking at Starknet Foundry. So what is Starknet Foundry? Starknet Foundry is a toolkit for developing smart contract on Starknet, and it helps us test our contracts and also like communicate with our contracts. Just basically do various things, but mainly for smart contracts. So like when we create projects, usually we use Scarb, but Scarb doesn't automatically give us like a way to create smart contract. We have to actually go in and configure the project for a smart contract. For example, I think this one is kind of configured already, but let me try creating a contract without Starknet Foundry. Yeah, this project is not necessarily configured for a smart contract. You can write basic like Cairo code, like you can see here. There's nothing that looks like a smart contract here. Or if you try writing a smart contract, it's not going to run. That's because in order to write a smart contract, you need to add extra things to the Scarb.toml. First of all, you need like something we call like a Starknet plugin that kind of can recognize smart contract code and all that and some other things. So Starknet Foundry allows us to be able to set up an actual smart contract project and also be able to test it and do all those things, everything relating to smart contracts. So Starknet Foundry is actually a tool on its own, separate from Scarb. But nowadays, it kind of comes like a little bit inbuilt into Scarb. Like when we try creating a project now, Scarb new or something, we can see it gives us two options. We can use Starknet Foundry and we can use Cairo test. So before this option was not available. Like before, you had to actually install this Starknet Foundry separately in order to use it to create a project. But now we kind of have it inbuilt. Although that does not mean you should not download it, because okay, let's just try and like create this project and see what happens. You can see the Scarb.toml is very different from the one that we had just now. It has like a dependency Starknet, has something called SM-Forge, which is something that is available in Starknet Foundry. It has something like a target that just says, okay, we are compiling this contract as a smart contract, and it's not like a regular Cairo code. And then also tells us, okay, we are enabling Sierra, which is very important. So let's go back to our slide. So Starknet Foundry itself, yeah.
Yeah, I have a question.
Okay.
Yeah, when I try creating a project with Scarb new, they don't give me the Starknet option. They only go ahead to generate the stuff for me. I don't know whether maybe it's the Scarb version I'm using.
Yeah, exactly.
2.6.4 for Scarb, then Cairo 2.6.3, then Sierra 1.5.0.
I think you need to update to like
what's the command to update it to?
I think it's not so easy to update. If you want to easily update Scarb, you need to use a tool called ESDF. Like if you check it out, so let me go to Scarb documentation. You probably have to uninstall it and reinstall it, but if you want a better way, there's something called ESDF, like you can see here. It kind of allows you to be able to easily install new versions of Scarb, or even Starknet Foundry, or even Starknet DevNet. So if you want to be able to easily like update whatever, try this ESDF to allow you to be able to like basically change the current version. Basically, just like in like what will I call it now? Like, you know, like the Python environments, yeah, something like that. Just basically create an environment. You can have different versions of Scarb installed in your system and use one particular one for your project.
Okay, I should uninstall it, then use that command to install it again, right?
Exactly.
All right, thank you.
So someone asks, is SM-Forge different from Starknet Foundry? No. So we're going to look at that question. We're going to answer it right now. So Starknet Foundry actually comes with two tools. Like it comes with, like, Starknet Foundry is not actually like a command. It's like a umbrella kind of package that comes with two command line commands basically. One is SM-Forge, sorry, and one is SNCast. So like if you recall, when we look at our project, we can see something called SM-Forge inside. And then there's also another one called SNCast. So SM-Forge allows us to basically test our smart contracts. And SNCast is basically almost like Starkli, but it's used for interacting with Starknets, like interacting with contracts, deploying contracts, declaring contracts, all those kind of stuff that we can actually do it with Starkli, but it's more convenient because Starknet Foundry is kind of inbuilt in our project already, like in our Scarb and everything. So it kind of makes it easy for us. Does anyone have any questions on what I just said? Does anyone have any question? Okay. So to install, have you guys installed Starknet Foundry? Okay. Okay, someone is asking for a definition of Starkli. I guess you were not in the previous class. Starkli is short for Starknet CLI. It just basically allows you to interact with, yeah, thank you very much. Allows you to interact with the Starknet blockchain, create accounts, create private keys, deploy, declare, anything you can do with like a Starknet node, communicate with Starknet node, and like just ask for information on everything. Yeah. So if you have Starknet Foundry installed, then you can try SM-Forge version. And you see SMForge is automatically installed. I want you guys to try that. Someone said I have an issue with initializing project using any SMForge in it. We'll go into that. Yeah. If you have also installed it, if you do SNcast, you have SNcast in your system. I can see I have SNcast version 0.30, SMForge version 0.30. So it basically gives you these two commands, and this one allows you to test, and actually it actually allows you to create projects just like you would do with Scarb actually, but it's mostly for creating smart contracts. While SNcast allows you to test. So let's try it out. SMForge, and let's do help. If your contract is not compiling because it's saying fetching from GitHub, it's probably network or something. So when we do SMForge help, we see tests, see 4 commands, tests, init. Init allows you to create like a new project, just the way we can create a new project using Scarb new or Scarb init. SMForge init allows us to create a project. Allows us to basically bootstrap a smart contract. I guess these are the only most important commands in SMForge. Allows you to initialize the project just like you do with Scarb, and then test the project. So let's try creating a project. SMForge init, and let's call it let's see this. Let's just say GIDAForge or something. As you can see, it just basically does what Scarb did for us. Like when we choose that option for SM Foundry, when we are selecting our Scarb, this is exactly what it does under the hood. So let's go into what we just created. If we go into the Scarb.toml, we can see exactly what happened when we did Scarb and we chose Starknet Foundry. It has a Starknet plugin as a dependency. It has something called SN standard. We'll look at that. And then like it has something called the target Starknet contract that is telling it, okay, this Cairo code we're compiling is actually is a smart contract basically. And then it has a script for testing SMForge test. So if you look into the file, the source folder were like in the previous file we created, there was no test folder when we use Cairo test. But this time it creates a test folder that we can write our test in. And then if you look at the source folder, we can see that it's very, very different from when we use Cairo test. They kind of bootstrap like a basic smart contract for us that we can now, and then also in the test, they wrote basic test also for that smart contract. So another thing that Starknet Forge comes with is this SMForge STD, which is basically like a standard library or something. So it gives us commands in our Cairo program to be able to like declare our codes like while we're testing. So this is basically like a test environment. And also like gives us something called cheat codes that allows to just do various like I don't know if I'll call them like magic tricks, but just like simulate the blockchain. We can like we can just test different scenarios like for our contracts, and also do something called force testing where we can just pass like different inputs and then the compiler will just fill it in for us. I'll kind of go into that later, but this is very important. This SMForge STD contains lots of like very important things that will allow us to actually test our contract. Does anyone have a question? Let me look at the chat. Does anyone have a question? No questions? Is anyone lost with anything I said so far? Does it make sense? Okay, so I want us to try and like initialize a project using SMForge and then like try SMForge tests and see what happens. Just test it on our system and see what happens. Okay, the presentation link. Okay, who else has created a project? Then try Scarb test and let's see what happens. Has anyone tried like Scarb tests? Anyone? Okay, while you guys are doing that, let's look at what we can do with the other SN casts. So let's do SN cast help. We can basically see kind of the things we saw with Starkli. We can declare our smart contracts, can deploy, we can call a contract, invoke a contract, can do something called a multi-call. We can create an account, can actually even do scripts. We can check the status of a transaction, we can verify a contract, and so on and so forth. So kind of what we could have done with Starkli, but it's kind of in our development environment. And I believe like Starkli is actually new. Like we didn't actually have Starkli until probably beginning of this year. That was just dedicated for interacting with the Starknet blockchain. So we're going to use these tools extensively in this class today. So let's go back. Does anyone have a question? Has anyone been able to like try the tests?
Yes, so but got some errors.
Okay, well, what did you say?
I think he's talking about the right function not present in. I don't know. I pushed it to the chat. Listen.
Okay. I said you should try SMForge test on
All
your
right.
project. Yeah, so not Scarb test, SMForge test. Scarb test is for it doesn't use SMForge tests automatically. Has anyone else tried that? So okay, let's move on. There's something I want to like. I'm sure we have been talking about this for a while, but like that we declare a contract and we deploy a contract, and like nobody actually asked me why. Why do we actually do that? Like, why don't we just deploy a contract? Like if you are used to something like in Ethereum, for example, we just deploy a contract, we just compile the contract and then deploy it, basically. I don't understand the error. Does not depend on Starknet package. Has anyone else tried it and just like it worked on their system, or is everybody getting this error? Oh, yours is still compiling. Okay. So in Starknet, there are 2 steps to deploy a contract. First, we have to declare the contract, then we can now deploy it. So like it kind of like I was saying, just like why do we have to actually do that? And it's actually because unlike the older blockchains, Starknet has account abstraction inbuilt. What does that mean? Every single contract, every single account, every single wallet is a smart contract. So they have to be deployed. Like it's not like on Ethereum that if you have a private key, you can just create an account offline and it's basically no cost. Every contract has to be deployed. So I want us to like imagine a scenario now. So imagine you are like a developer and you are in charge of creating like a wallet now, an agent wallet and a OpenZeppin wallet, whatever wallet for your users. So are we going to now deploy that code now? We have written our code. Are we going to deploy that code for every single person? Like, okay, we say, okay, Victor now has like, he wants a contract and we'll now go on our terminal, click the right deploy and deploy it every single time. That's kind of a waste, right? So that's why there's actually like a step before, which is declaring. So what declaring does is like, it allows you to basically register code on the blockchain. So you have written your code, you register it, and you kind of, that Sierra code now, you declare it and register it on the network. So that code is available on the network. So anybody that wants to deploy just needs to like access something called a class hash. A class hash is basically like a blueprint to that contract you have deployed. So anytime you declare a contract, you get a class hash back. And with that class hash, anybody can redeploy that, like use that class hash to now create a contract. So what I was saying, you can have like an infinite amount of contract with the same code. So, and in order for that to work, you need like the class hash. With the class hash, you kind of deploy like an instance of a contract. Like every contract has its own address, but they share the same class hash, basically. Does that make sense? Yeah. So every ERC20 contract. Okay.
Sorry,
Yeah.
sorry. Please, what you're saying is that different contracts can have the same class hash.
Yeah, exactly.
Okay.
Yeah. So the class hash is actually generated from the code and some other information, like when you declare it. So just imagine every ERC20 contract now that we deploy, they basically kind of have the same class hash. Every agent wallet, for example, now they have the same class hash. Every Bravos wallet has the same class hash. As long as it has been declared, and once you declare a contract, you don't have to redeclare it again. Basically, you can use that class hash as like, I don't know if you call it like a constructor, if you can think of it like that, to kind of create more contracts. Okay, someone is I should explain again. So what don't you understand, like in what I just said, like the part that is confusing the most, Olufemi?
You've just explained it. Thanks.
Okay. Yeah. So that's why there's a declaring process. So that we have already registered that code, that our Sierra code on the blockchain, and then from that we can recreate like multiple smart contracts, basically, as much as we want. So you can see declaring registers or stores our Sierra code on the network and gives us a class hash. That class hash serves as a blueprint for our contracts, enables us to deploy new instances of our contract without needing the code again, because the code is already on the network. And also we can deploy contracts that were written by other people. Like we don't have to always write the code. If somebody has written an ERC20 contract before, we can just look for the class hash and just deploy it ourselves. And like I said, if the contract has already been declared, you don't have to redeclare it. Like if you try to declare a contract that has been declared, to throw an error and tell you, okay, this contract has been declared, and okay, it will now automatically give you like a class hash to deploy. And what this is insinuating that to deploy a contract, they are going to ask you for a class hash. Like you cannot deploy a contract without a class hash. That is like necessary. So that's kind of insinuating that you have already declared a contract, and that's like a prerequisite to deploying a contract. Does that make sense? Okay. Is there anybody that is confused? Anyone that's confused? Yeah, it kind of sounds like deployment, but it's like a precursor to deployment, basically. Like, if you guys recall, when we created our accounts yesterday, this is the file. You can see my screen, right? Can you see my screen?
Yes.
Okay, when we created our accounts, the accounts we created last time, it had the class hash, and I told you guys that we're going to like explain it later. So this class hash basically is like a class hash for an opening Zeppelin contract that has already been deployed, and it now allows us to now redeploy another like basic accounts with a different address but the same code. So that's like something that is very important. So that's why we have like a declaring and a deploying process. So today, what we're going to do, we're going to write like an ERC20 token, and we're going to try using SM4 and SMCAS to like basically work with the contract. So I want you guys to follow what I'm doing. Is there anyone that's still confused with declaring versus deploying? But it's like a very important concept, and it's kind of unique to Starknet. Yes, exactly. Like basically putting your code live on the blockchain. It just stores your code, registers it. Deployment is calling. Deployment is like if you are used to object-oriented programming, where you have like you have written a class and then you click new or something, and then you now create like a new instance of that class or something. It's basically the same thing. It creates a new instance that has like an address that you can now call. Well, you can't really call like a class hash, can you? So yeah. Yes, to declare a contract, you actually have to pay gas fees. It's also a transaction. It's also like a transaction. We have a deploy transaction. We have a declare transaction. So to declare a transaction, you have to pay gas fees. It's not free, unfortunately. Anyone has any question about declaring? This is actually a very good question. Anyone has a question? Okay. Or should we try like declaring the contracts, maybe? How do you know the contract has been declared before? So if you try to declare a contract that has already been declared, it's going to tell you that this contract has been declared already, basically. Any other question by going to the contract? Okay, it seems like there's no question. And like I said, declaring is not like if you have already declared a contract, you can just go ahead and deploy it. You don't have to declare all the time if it's already declared. So I'm going to be creating like an ERC20 token. What we're going to use as a reference, I'm going to use this as a reference. This contract, I'm going to copy it in the charts. So this is some Starknet by example. You can come here and like basically learn about Starknet, like mostly Cairo, like you see different contracts, like how to test a contract, basically everything. But what we're looking at today is this ERC20 contract. How many people are familiar with an ERC20 contract? What is it? What it is rather? I think I recall the last tutorial kind of actually you guys wrote an ERC20 contract, right? Am I wrong?
No, you are right.
Okay. So we're going to be doing the same thing. So an ERC20 contract is basically just like a fungible token. Like we have these links should be posted on WhatsApp too. I'm not on the WhatsApp group. I think I'm on the Telegram group, so I don't think I can do that. Or if somebody can copy this and just paste it on WhatsApp, that would be nice. Okay. So an ERC20 contract is basically just a token. Like, we have the Stark token, we have Ethereum token. Which other one again? Like all the basic tokens that we know, like Solana, although Solana is not an ERC20 token, but it's also an example of the token. So an ERC20 is like a standard, or every token on Ethereum are supposed to have like a certain functions, like so to have certain functions that you can call on them, so that basically so that all of them can be compatible with each other. So ERC20 is like a standard, and it originated from Ethereum, but we are using it in Starknet also. So these are the functions that a contract you have. Basically, every contract has a name. The name could be wherever. It has a symbol, which is just like 3 to 4 letter words that represent, like, for example, we have ETH, decimals, we have total supply, we have a function to get the balance for an account, something called an allowance. Allowance allows like other people to, like, you basically just give people the right to spend your tokens. We have a function to transfer. This also does the same thing, transfer from, to approve, to increase allowance and wherever. So let's just copy this traits because we're going to be using it. Let me create a new project using I'll use Scarb new GIDA token. I think I've used GIDA token before. So let's say GIDA ERC20. And I'll choose Starknet Foundry. So this code that I created for us, not just go ahead and like delete it. Just put it here. Put the just got from.
So there is no movement on your screen again.
Oh wow. I think we had this issue yesterday. Let me try on
Yeah,
share.
it's working.
Let me try on sharing my screen again. Presenting. Okay. So when I put it on full screen, can you see it? Can you see it?
Yes, we can see it, but try moving your mouse. Let's see.
Okay, let me try typing something. Can you see what I'm typing?
No.
Wow. I guess I'll have to like use my screen on like minimize my vscode. I guess you can see it now.
Yeah, we can see it now.
Yeah. So I'm sure you guys have been introduced to what traits are basically. So trait is basically like interfaces in other programming language, just a collection of related functions. And these functions now, they are related to the contract, the ERC20 contract. Allowed us to get the name and everything we just discussed. So on Starknet, to specify that a trait is actually like a Starknet interface, we have to put this Starknet interface. So it's showing an error now because we have to import something. Like we have not imported contract address, so let's do that. So to import in Starknet, we use the use keyword. So we say use Starknet. And the contract address. And the error should go away. Yeah. Yeah. So every contract, someone is clapping. Why are they clapping? Every contract is contained in what we call a module. So let's create a module ERC20. Does anybody have like any issue with this module that we created? Like, let's say they don't understand or something. Okay, why did we use Scarb instead of SMForge? Like I said before, we have to use SMForge to create a project, but now SMForge is kind of available as an option in Scarb. You get, so it's the same thing as using SMForge in it. Like they just basically give us an option. So that's why I did that. Someone said more like ECMAScript for JavaScript define rules. So I don't really understand the question. I don't really understand the question. If you can, like, say question again. So yeah, like I was saying, is there anyone that doesn't know what a module is here? Anyone? I was confused with like modules. Which is better, bootstrapping a project SM4 or Scarb? It's basically the same thing. Like, there's no difference. If I created SM4 init, Scarb init, and then select SM4. Okay, I don't know if you guys didn't see this when I was doing it. Like, if I do Scarb, if I do SM4, okay, Scarb init, rather. Let me try that. Scarb new and see wherever. It gives us two options. There is Starknet Foundry. So it kind of Scarb now is like a new update, but Scarb allows us to bootstrap and a Starknet Foundry project basically. Well, if you don't want to, you can just do SMForge init and do the same thing basically, but they kind of have the same outcome. Okay, I don't understand. You say you were explaining the ERC20 token. Yeah. Are you don't understand it, or should I re-explain? Is that what you're saying? Okay, is a token standard basically for all Ethereum tokens. Every single Ethereum token, USDT, USDC, even Starknet token, all of them, they follow this ERC20 standards. And like basically, you know that we are going to interact with, like anybody can interact with like a token, and we want them to know the functions that they can call. So every single token has the similar set of functions that you can call for compatibility. So it's basically a standard. Yeah. You think you prefer the Scarb way? Me also I prefer the Scarb way. But basically it's the same outcome. I think Starknet has just basically made it easy for us. Because usually before, I would, if you want to create a smart contract project, you have to use SM4 basis to create a project. But now they have made it easy, and they have integrated Starknet Foundry, that's the SM4 part, into Scarb itself. The SM4 never forged since. Yeah. But we're still going to use SM4, so don't worry. It's not like we're discarding it or something. Yeah. So we have to give this like a macro to show that is a contract rather. Okay, it's telling us that we need like a storage struct. So Starknet contracts, they are divided into like two portions. We have what you call storage, basically where all your storage for your contract goes, and then we have the body, which is like an implementation of this traits that we just defined. So I want us to copy. Then listen, the pub before the mod, is it necessary, right? Okay, it's necessary. Yeah, it's actually necessary. Pub basically what it does, it exports. It's basically like export default in JavaScript or any other programming language. It exports this trait so that we can use it outside. So now make it visible outside this lib folder basically. Although normally when we are creating projects, we're not going to write it in the lib.cairo. We're going to create like it's like okay, let's just do that. ERC20.cairo. And then let's just copy this here. Copy everything here. So like we said, this lib.cairo is our entry file. We can have multiple contracts. We don't have to have one. And it's just our entry file. So we have to kind of define it here, like tell the compiler that, okay, we have an ERC20 contract. Do ERC20. Yeah, and now if we try to build it, it doesn't build because we haven't given like a storage. Lost to that. Did that answer your question on the pub? What pub is? Right now, if we didn't give it a pub, now we can't access this trait outside of this ERC20 this ERC20 file because of the pub. Now we can now, if we want to import it anywhere, and we're going to need that when we are writing tests, we are going to need this trait basically. So I want us to copy the storage from here. We are going to change this, so don't worry. So like I said, every Cairo contract must have a storage. And this is basically what we store inside our ERC20 token. Okay, I guess we have to import all these things. Before that, in our ERC20 token, every token has a name. Like basically what this function is fetching. It's fetching the name. We have to store it somewhere in the storage. It has a symbol, that's a decimal, total supply, then like a mapping for balances and also our allowance. Loss imports. Contract address, then also storage and mapping rather.
No movement on your screen, sir.
Oh wow. Can see it now, right?
Yeah.
You know, see that the error has disappeared. Like we're saying, every ERC20 contract has a name, the symbol, decimals, the total supply. That's like the cap. You know, basically when you're launching a token, you have like a cap that okay, we are only going to distribute 2 million tokens or wherever. So that's basically the total supply. This balances is basically it's basically mapping every person's contract to their balance. So it's just storing like every single person's address and saying, okay, for example, my address, I have like 2000 wherever the token name is. So that's what it does. So a mapping is basically like a key value pair. That's a key here, which is the contract address, and then the value here is the balance that you have. So I think we have to change some things. First of all, let's change this to a byte array. Byte array is basically a string. It's called a byte array, but it's just a string. Change this also to a string byte array. Decimals okay as it is. Total supply, we have to use a U256. Balance is also U256. So this allowance is what it's doing is basically you want someone else to, let's say you want someone else to be able to spend your token for you. Like this scenario is like let's say you want to give a DApp access. Sorry, byte array is larger than, yes, exactly. Like 52 is like a string. It's limited. It's like 31 characters or so. But with byte array, you can have like any amount. It's basically like a global string. You can have like any amount. So that's why I think we should use like a byte array. Yeah. Yes, it is.
Hello, sir. I have a question.
Yeah, I can hear you.
Yeah, you imported a Starknet contract at the top, but you still have to come and import it.
You mean the contract address?
Yeah, contract address.
Okay, so
And you imported it in the mode again.
Yeah,
so
yeah, okay, I can hear you.
Yes, is it that this particular one, the scope, is it not seeing the mode, the one inside the mode is not seeing the one outside, or?
No, modules are like, they are isolated. They can't interact with the outside or the inside. Like I can't access anything that is not in the scope, basically, like you said. So although there's a way to, if I want to be able to use this inside the module, there's actually a way. There's something called super. If I use super kind of it allows you to like how will I put it now? Access something outside of the module, like any basically a parent code that's outside of the module. I do super contract address, I'll be able to access it.
Okay.
Same thing. Or you can just import it the same way, Starknet contract address. So I can actually even like these traits that we use now, I can also get the traits. I think it's IRC20. You see, I can import the traits from outside the scope. Get. Does that make sense?
Yes, sir. Yes, sir.
Super all, I don't know if that works right now in that. I think that will work in Rust, but I don't know if it works right now in Cairo. I think I've tried it before. I don't think it works like that catch all. Okay. So like I was saying, these allowances, like sometimes you want to give a contract, like an app, a DApp rather, permission to spend token on your behalf. You understand? Like sometimes there are some cases where you want to do that. Like you want to give like a tab that you trust. Okay, you can send. Maybe they can almost schedule like a transfer 2 days from now. You understand? So these allowances allow you to now say, okay, whatever contracts I'm going to give them. Let's say I give them access to 20 of my tokens or wherever you get. So that's what this allowance does. So that you can allow like a third party to spend on your behalf. So these are like all everything we need to store for an ERC20. So what I'm going to do now is try and implement this ERC20, like all these functions. And we'll do that using an input block. And then we actually need to, this is when we actually need that super again. So we can have access to this traits that we defined. Okay, it's telling us that we need to implement the traits. So the first one, get name. Let's just copy this. So I think I also need to change some things here. Like since I said we should be fetching a byte array, let's make this return a byte array also. Symbol also. I guess this one we have to change to U256. Balance of same thing. And allowance same thing. Transfer doesn't return anything. Approve doesn't return anything. Increase allowance doesn't return anything. Let's implement the get name function. Does anyone have any like question on like the syntax? Any syntax that is kind of confusing them? So we have to pass the contract state here. Does anyone have a question on the syntax? Something that is confusing them about the syntax that doesn't make sense? Anyone? Okay, so we're going to return the name, whatever name is stored, self dot. You can see it basically gives us autocomplete. So self dot name should be name, right? Yeah, name dot read. So if we go back to this our traits, you can see like some functions have this @ symbol, while some have a ref. So what this represents, this is something called a snapshot. Allows us to read states. Like basically we said we have two types of transactions. We have one that reads and one that writes, basically. So when you use this @ symbol, you're just telling us that this function is only going to read from the contract. And this contract is represented by this self. And when we see a ref, which is a reference, it's telling us that this function is going to write to the contract. So is that clear? So anytime you see this @ you just know that, okay, this function is reading. You see the ref, you know that the function is writing. So all we need to do here is just self.read. So let's go to the next one. Just implement the next function. Get symbol. Is anyone lost? Are we all following? Are we all following? Are we all following? Okay, someone said yes. If you're lost, you can ask a question, please. Does your yes mean you're lost or you have a question? So we're going to do self dot. Is my terminal clear? I think I need to close this thing so you guys can see it very well. Self dot symbol. Just read the symbol from storage. Let's read sorry, dot symbol, that's read. So if you guys noticed, I'm not giving these functions any return statements. Like I'm just writing it like that. I'm not putting like a semicolon or wherever. That's because like Cairo, just like Cross, has implicit return. So if you are returning something, I'm returning a byte array, you can just write it and you don't need to write a return statement basically all the time. And just write it implicitly and it's automatically return. So let's implement the next function, decimals. All these functions we're not really doing anything special. We're just returning whatever is stored in storage. So get decimals. Once the U8. What about the semicolon? Yeah, I think I just explained, right? Do you just need an explanation? I said when you are returning something in Cairo, just like Rust, you don't have to explicitly, you can do this, you can do a return and then put a semicolon. Yeah. But you can just return it implicitly. And when you do that, you don't need to add a semicolon. You only add a semicolon when you are returning like explicitly like this. So once you just do this, it automatically just returns. You don't need to like put a return statement or a semicolon. If you put a semicolon, it's not going to work. Semicolon only works when you are using like a return statement. So this just returns whatever decimal. This is self dot decimal dot read. You can see all these functions. They are basically just reading from smart contracts. I think it's decimals. Am I spelling something wrong? Decimals, yeah, decimals. Decimals.read. Okay, I need to change this to a contract states. So you did not, yes, I'm going to do a constructor. I just want to like implement all the functions first. So I'm going to do a constructor. So you guys have kind of been noticing something, this contract states that I passed in, like where exactly did I get it from? Like nobody has asked me, like, did I just, like, where did I get this contract state type from? Like it's basically a type, just like the contract address. Where did it come from? So if you look at the storage now, we when we declare a storage, we always have to put this storage macro, and automatically when we build our contracts, it now creates this contract state type for us. So that's why we can just use it freely before we compile it. So this contract state type represents everything here in storage, basically, like everything that we put in our storage. So the next get total supply. I just basically just try and speed it up. Let's read. I think I spelled it wrong. That's correct. Okay, I don't need to put, like you say, I don't need to put the. I also need to change this to contract states. Yeah. So like we said, the balance of what it does is it gets like a balance for a particular address. Like you can see it's asking for an account that we want to check the balance for. So I'm going to do self dot balances. I think that's what it's called. Balances. Yeah, balances dot read. And then we pass in the account I want to read. Yeah. Then we have I don't think we'll implement everything. We'll just try and implement like the most important ones. Let's do this transfer. I think maybe I should just now try and explain it. Can you guys still see my? Can you still see my terminal? My VS Code rather. Can you see my VS Code?
Yes, we can see, but now that you've made it full, we are not seeing any movement again.
Okay, I'll reduce it. I'm coming. This reduction is making it hard, making me have to scroll all the time. Save the balance of read. Can you explain what that line does? Okay. So we have these balances in our contract state, and we said like a mapping is a key value pair. You understand? So you have a key which is a contract, and then a value that you are reading, which is like the actual balance of the account. So for any of this like this state now, we can read and we can write to it. So to read to it, we do self, which represent the contract that whatever we are referencing, just read to read it. But for a mapping, it can accept an argument, which is this this key that we are passing out, this contract address. So that's why we now say balances dot read. We're not reading information about an account. So does that make sense? Does that make sense? I'm Hillary. Okay. So we want to transfer a token now. We're transferring from to, and it basically gives us like who we are transferring to. Does not tell us who we are transferring from. So in order for us to get who we are transferring from, we have to get the person that calls the contract. You get. So to do that, that's what this get caller address does. So you can actually just way import like the contract address or wherever type you can import it. But me, I just prefer to just call it directly rather than importing too much. So the Starknet get caller address. So this get caller address gets the address of whoever is calling the contract. So we can see it returns the contract address basically. So whoever calls that contract, whoever signs the transaction, or whichever contract calls the contract, it will give us the address. So why we need that information is so that we can just to see like check if the person that is trying to transfer is the actual owner of the whatever token. Yeah. So let's just try and transfer. We see self. Let's get like the balance of. Okay, so in order to do this, what we are going to do is, why not using core Starknet? Like Starknet has something called a prelude, which kind of makes a lot of these things, like not everything, but some things are available by default. You don't have to import everything. Like for example, like Starknet, for example, now is available by default. And I remember when we installed Starknet, it came with a Starknet plugin. So this is kind of automatically injected into our thing. So we don't have to like use core Starknet, like this Starknet keyword is kind of available by default. Does that make sense? Not everything is available, but some basic things like for smart contracts or wherever they are available. So you can just go ahead and just say Starknet get caller address. Does that make sense? Does that make sense?
Sorry, please come again, please. I'm sorry.
Okay, your question. I'm answering this question on the person said, why aren't we using core Starknet? Like, why can I import by just saying Starknet? I'm saying that this Starknet command now is available by default. Like you don't like there's something called the preludes, which just contains like the common functions we are going to use, basically things that we use commonly. They're available by default in Starknet, so you don't have to always use this core all the time. You can just use Starknet. And also, like, remember when we created a Starknet Foundry project, we have a dependency Starknet. So this kind of injects Starknet into our environment, so we don't have to always import Starknet all the time. But we don't have to import by using core rather. That's what I mean. Does that make sense? I don't know if that makes sense. Okay. So we want to transfer a token from one person to another. Let's get the balance of the person that is calling. Let's see let's sender balance is equals to. So what we want to do is decrease somebody's balance, increase the other person's balance, basically. So we say this sender that we call now, say self dot balances. Can you see I think I need to reduce this so I can see everything clearly. Yeah, just can see it now. Self dot balances dot read, and then we'll pass in the sender, and this will give us like the balance of the person that's calling the contract. So first of all, we have to check that this person actually has money to send to get. So we use this assert macro. The assert macro is just like what we have in like, has anybody used Solidity before? We have like a panic, or I think it's what is it called? I don't remember what it's called in Solidity, but no, not an if statement. What's it called in a require statement? In Solidity, it's called require. That it kind of like if a condition is not met, the program just crashes it. Your smart contract, basic transaction fails. Get what I'm saying? So it just panics and just crashes the whole contract. So we're going to confirm that the sender balance is greater than 0. So whoever is sending actually has to have like more than 0 in the accounts, basically. And if it's not, we will pass an error. Let's see, insufficient balance. Is anyone confused with this assert that I just mentioned?
Hello, sir.
Yeah, I can hear you. I can hear you.
Can you do the sender amount greater than or equals to the amount that you want to transfer instead of 0? That's the amount you passed into the argument, into the parameter there.
Yeah. Actually, we also have to do that because we have to check that the person actually has the same, like, is basically the amounts I want to send. The person does not have less than that, so I guess we still do that.
Okay.
Or
Okay.
we are going want to show like, okay, insufficient balance. But I guess we can just do that directly, like greater than or equals to, not just say amounts. I think that should catch everything, including 0. I'm having an error. I don't know why. I think I need to. If it's true, it throws an error, right? No, if it's false. So if it's true, it just passes basically and goes to the next line. But when it's false, it crashes. Hmm. I think it's from the types. Oh, okay. Oh yeah. This amount we're supposed to make it like a U252 also. Same as the balance U256. Yeah. I guess we have to change in our rate also. Transfer, change to U252. Or U256 rather, sorry. Still showing an error.
Try byte array instead of
Still doesn't work. Supposed to be, oh, it works for some reason. Well, maybe some things have changed, but usually it's a fault that will pass. Oh yeah, we have cleared the error. So if this doesn't pass, if the person does not have sufficient balance, it's going to say insufficient balance basically, but the person is going to continue. So now let us now transfer from, so we have to reduce the balance of somebody and then increase the balance of that person. So we reduce the balance of our sender. Okay, you say you are using assert. Yes, exactly. Assert is a macro. You know, all macros have this bang at the end. So it's not a function, it's a macro that we're calling. Yeah. So let's reduce the balance. Let's just say new sender balance. I'll say self dot balances dot writes. Now we want to write to the sender. Then we have the old balance. So we're going to reduce the old balance by the amounts. So we say sender balance minus amount. Yeah, this is the person's new balance, and then we're going to increase. We don't actually have to put this in a variable, but let's increase the balance of the recipient. So let's say recipient balance. Let's say self dot balances dot write. Now see recipients. So I guess we also needed to like get the recipient's address. Let's see, and recipient's balance rather. Recipient balance. Now see is equals to self dot balances dot read. And they will pass the recipient address that was passed to contracts. And then what we are doing here, you notice that we're kind of repeating. We don't implement gas fees to be used for our code, right? No, we don't. So like you notice that I'm redeclaring recipient balance 2 times. Like I wrote it before, I'm writing it again. So this is something called shadowing in Cairo, and Rust is also available in Rust. It just allows us, like, we can redeclare a variable that we have declared before. So I don't have to name this a separate thing because it's basically the same thing. It's like the new balance. So I could have actually just like rename this as sender balance also, like sort of giving it like a new balance. I'm redeclaring it. That's what shadowing is. So I'm going to change the balance and say the former balance, former recipient balance plus the amount. And I think we have to return. We're not returning anything, so I guess we don't actually have to even call it in the variable. We can just remove it and just call it like this. Or at least I've shown you guys what shadowing is. The same as using the mute keyword. What do you mean? What exactly do you mean by is same as? What is same as using the mute keyword? Okay, no, it's not same as using the mute keyword. I get what you're saying. Like when we use mute keyword, like for example, if I use the mute keyword now in this sender, it means I can change the value of the sender. I can just come here and say sender equals to and change the value. But what I was doing there, I was not changing the value. I was redeclaring it. So I'm basically repeating this whole thing again, like redeclaring it. And it's called shadowing in Cairo. So like it just basically allows you to redeclare values that were already, but when we're declaring, we're basically changing the value. You understand? So do you understand that? Does that make sense? It's kind of different from mutating something. Okay, so we have reduced the person's balance while increase the balance. So this transfer is going to work. So this transfer form basically does what the transfer does, but it's taking two arguments, taking both the sender and the recipient, basically. So we can just copy this. Just copy this. And I guess we don't actually have to pass the sender here because the person, whoever is calling contract, is passing the sender. But we have to do a check actually. We have to check that whoever is calling this transfer function is also the same with this sender here. Am I going to push the code to GitHub? Okay. I guess I will do that after the class and I'll share it with you guys. So let's like check, confirm that whatever account they are passing as the recipient is the same with whoever is calling the contract. So we see assert. I'll see the sender. Okay, let me call this caller instead, just so that it does not redeclare the form of the sender that they provided here. So we see the caller is equals to the sender, and if not, say invalid caller. Apart from that, every other thing should work the same way. I think we actually need to, like, remember we changed this to U256. So we need to also change it here to our traits transfer from. Okay, so that error should go away. Yeah. So now we are the approve. Like remember I said approve allows another person to basically spend our token. So it takes two arguments, the spender, where we're approving to spend our token basically, and then an amount. So let's do that. So like we can see here, it doesn't actually give us like who are we approving for? It does not give us. So we are going to have to like do it manually by saying Starknet get caller address. So it gives us like the address of whoever is calling the contract, like we did before. Then we'll now see, so to like approve an amount, we say self dot the state here was allowances I think we actually need to read the allowance just in case that we have already given, like, allow the person to spend a particular token, so we are not rewriting it. So we say previous allowance. And then we read the formal allowance I will give the person. If it's 0, no problem. So we have to pass in two variables. This one represents our own contract, the caller address, and this one represents the person we are allowing to spend our token. So we say we give you a caller and then spender. Saying wrong number of arguments needs theory. It actually needs theory. No, it just needs to. Okay, I think I understand what's going on. This accepts a tuple. I think I'm supposed to pass a tuple rather than just passing it directly. You guys know what a tuple is? Sure, you guys have been taught. So this accepts a tuple, the color and the spender. So now let's approve for the person. We'll now see self dot allowance dot rights. Passing the same argument I'll pass here. Let's just put this in a variable. Select allowed person. Then we'll now just put this. I will now have to call it over and over and over again. And here we can just write allowed person. Why do you have to use a tuple? Like in the allowances, we defined a tuple. Like we need, like in the balances, we're just mapping one thing, one person to a balance. But in our allowances, we're mapping two people. Basically, we're mapping both the owner of the token, like the person that we want to allow, and then the third party that you basically want to allow to spend. So we have to group it in a tuple, basically. Yeah. So I put this allowed person now in a variable, so we don't have to be repeating this tuple all over again. So allowed person, and then we now to write the allowance. So the new allowance is going to be the previous allowance plus the amount. I'm getting an error. That's not meant by allowance. Okay, sorry, it's allowances. I think, yeah, allowances. So we basically have written a function to approve our contract. Does this make sense? Hope I've not been going too fast. Is there anything so far that you guys have not understood? Any of the functions, the transfer, and the approver? Anybody has a question? Please ask now.
Yes, I have a question.
Yeah.
I noticed that in the approve function, you are passing amount as spelled 252 instead of 256. I mean, is that supposed to be so?
Oh, okay. Yeah, you're right. I'm supposed to change this. It's not supposed to give me an error, Seth, because I can't add. It's supposed to give us. I'll change it. This was what
I think why it's not giving an error is because even in at the top as well, it also felt 252.
Yeah.
That was under the allowance mapping. No, not there. Scroll down.
Approve.
Under the contacts. Yes, it's also exactly, yeah. I think one more place as well. Under the contract, somewhere in the contract, I think there's also a place you did something like that. Okay.
I need to change this.
Okay.
Hello, sir. My question is on line 86.
Okay, line 86. Okay.
Okay, you are using these words interchangeably. You are using caller, owner, and the so the caller. I want to ask: is it a Starknet keyword, or you just use a? I was expecting to get an owner, or
It's not a keyword. It's just a variable.
but I'm seeing caller. I'm seeing
Yeah.
caller and
Seeing what? Yeah, you are referring to this color, right?
you understand my
This,
question?
yeah, I think I do. This color.
Yes. Is he a Starknet keyword, or
It's not.
because I was expecting to
Just a
either
variable.
be a sender? Okay.
It's just a variable. Like when you are defining variables, you have to be very descriptive. And I said get color address is getting whoever is calling the contract, basically. The contract that you have seen owner, why they use owner is because those contracts, they are probably ownable contracts, contract that they are owned by somebody. So that's why they use let owner. But this time we are referencing somebody calling the contract. That's why I called it a caller, just to be
Okay. I can choose to give it any name I want to.
Yeah,
Right?
yeah, exactly.
All
You
right.
can.
All right.
So our previous allowance, I think in our state we didn't change this. Yeah, supposed to return it to U256. Any other person has a question so far? So I've been able to write function to transfer and also approve. So the approve kind of like it's kind of always increases, basically. Like you're saying, you're setting an amount that you want the person to approve, basically. But these two functions, what it does is you can increase allowance for somebody you already set approval for, and then you can reduce the allowance, basically. So normally we're supposed to just repeat this. The higher the data types, the more computation is needed, the higher the gas. I don't really know about that. I think the gas is probably depending on the amount of code, because we are just reading and writing to states. Yeah. Well, I guess you're kind of right. But we can't do without using like something like a byte array. All these types, they are very they are necessary. And there's no like a cheaper alternative. And gas is not really like a problem on Starknet, because basically Starknet is cheap. Gas fees are cheap. So it's not necessarily like something you need to always bother about. Like in Ethereum, that you always have to optimize every function. You understand? It's not like you should not optimize. You can always save your users gas fees, but like it's not like a concern for us. You get. So this kind of increases the allowance. So we'll just copy exactly the same code as here. Change this to U256. Added value. We copy the same thing here, because they are kind of doing the same thing. But this time we are reducing the allowance, so it's going to be a minus. Minus reduced value. Subtractive value, rather. Make it a U256. So someone says, so the gas fee is based on the size of the code. Can you differentiate allowance from approve? Okay. So I think in normal ERC20 contracts, I guess we are actually supposed to have. Wait, let me look at the approved doesn't return anything. So let's look at the approved here if I did anything wrong. Like, okay, does exactly the same thing that we did. So difference between allowance and approve. It's not like there's a difference, but it's like this approve is like it's basically just like before. Normally, I think they used to have like a variable here that would have like approve, and then we can now say like true or false to see, okay, is this person approved to spend our token? Like, does this person have like enough allowance to spend our token? You understand? So that's what usually the approve is supposed to be doing, like say, okay, true or false, person is approved or something, I guess. But it's basically the same thing. Doesn't really do anything. Just that the increase and decrease, one is increasing, one is decreasing. But the approve is always increasing, you get. Like you're just directly saying, okay, approve this, spend 20 tokens or wherever. And then when I now call transfer from, like it will now work. Yeah. So there's something we didn't actually do. When we were transferring, we only allowed the caller to transfer, but we're also supposed to like allow somebody that has been approved to be able to transfer. You get what I mean, right? Does that make sense? Does that make sense? Anybody answer? Like, yeah, it's not just the owner of the owner of the token. We also are supposed to allow like whoever is approving the contracts, you get to be able to transfer. Whoever has been approved to spend, rather, to be able to transfer. So I don't know if we can add that also. So we checked if the balance, person has a balance. We can also check if the person is approved. So say assert, that's a self dot approval. I think it's approval, right? Okay, we do allowances, right? Allowances dot read. Then we'll pass in the recipients. And we'll check if this allowance is greater than 0. And if it's not, we see not approved to spend. So it's giving me an error. Maybe we'll put this in difference between assert and. I don't think there's an assert. There's only an assert macro, like an assert with a bang, because it's actually a macro. There's no assert function itself. It's the assert macro. That's what. There's no just assert. The assert in Cairo always has this bang because it's a macro. So for some reason I'm getting an error. I don't really know why. Let me. It's from this our code. Let's write it again. Self dot allowances dot read, and then we'll pass in the recipients is greater than or equals to 0. Let me try putting this in a. Okay, yeah, we kind of are actually already put this in a variable, so not just use it directly. Okay, I know why it's not working. Oh, it's working now. Yeah. So we're going to duplicate this. So this checks that the person is also allowed. So if I think we're actually supposed to do an all statement, because let's just kind of put this in one statement. Do all. If the person is the sender and he has enough balance, or whoever is an allowed person. Oh, sorry. Can you add comments when you push it to? Okay, I'll try and do that. Let's see allowed person instead. Because this is actually reading from like the balance. It's not actually reading from an allowance. So let's say self.allowance dot read. Then we see recipients. Then we can now see for allowed person balance. Is greater than or equals to 0. And that should work. In Cairo, there's no assert macro like in Rust. Cairo only uses assert keyword function differently from. As you can see, I've been using this assert all this while. Like assert is a macro. Like let's try. Luckily, this my VS Code has like an autocomplete. I use an assert. There's a macro. So that's what we use all the time. I won't really use like an assert function, but it's mostly just the macro. For some reason, this isn't working. It works also. Oh, okay. Identifier not found. Okay, I've changed allowed person balance. Still not working. Has no member balances. Are you guys like with what we have done? If I tell you to like write an ERC20 like basic, can you think I'd attempt it? If you can't, can you tell me where you think you have an issue? Anybody say something? Okay. So we kind of understand an ERC20 token, right? This is supposed to work, but it's not working. Let me just remove this and see. I think it's probably my VS Code that is behaving, because this is supposed to work. Hey, Larry, well, are you saying you can do it or not? So I'm going to like edit my VS Code and enter it again, because I'm sure my code should be working. Yeah, see, it was just being stubborn for no reason. Oh wow, okay. Hmm. Is there any questions? Well, you understand what I was trying to do here. Yeah, both somebody that's allowed can transfer, and somebody that is the owner of the token can also transfer. Let me see if I can figure out where my error is coming from. They don't have like, okay, they have some asserts here. I recommend coding parentheses. Let me go back to the way it was while it was working. So this is supposed to be working, but for some reason, it doesn't want to work. Oh, I think I know why it's throwing an error. Is the transfer supposed to return anything? I don't think so. Hmm. So I'm sure my code is correct. Can't really. Someone say something.
So is the piece of code supposed to be in transfer from or transfer?
Like they kind of do the same thing. They do the same thing, but the transfer just gives us one argument who we are transferring to the recipient. Transfer from gives us both the sender and the recipient. So I guess let's just to like remove that error. Let's copy what we see here because it's doing the same thing. Let's try and reset it back to normal. I just want to show you guys something else. Yeah. So I guess it's working out for some reason. Caller equals sender. So we don't need this one. So let's go back to our test. But you get what I was trying to do to ensure that when we transfer this this thing, like either you are approved or you have enough balance. I don't know why it's not working, but I don't want that to delay us. Yeah, it's probably my VS Code extension actually. It does that sometimes. But I just want you guys to get that. So it's still telling us that we still have some functions that we have no. Okay, yeah, I have to put like a semicolon here. This could have been why it was not working all along. say not all trait items are implemented. So there's an allowance that we have not done. And this allowance, like remember I told you guys like there's like a state variable now that tells us, okay, is this person allowed to spend our contract? So this allowance function is kind of like a replace for that. It just tells us, okay, how much is somebody allowed to spend from our token? So it just returns like it's basically a read function, just returns what the person is allowed to spend. So let's copy this. Okay, it's 10:40. Okay. I guess I'll be rounding up. All we just have to do is it returns a U256. Say self dot allowances dot read. Then we're passing a tuple, the owner, and the spender. Yeah. So this is kind of all for our ERC20 token. And we'll be deploying this contract the next class using SMForge. Fortunately, we spent a lot of time writing these contracts. Our goal was to write this contract and then use SMForge and SMCast to like deploy and test the contract. But at least we have introduced SM Foundry to us. Like I said, SM Foundry contains SMForge for testing our contracts and also SMCast for deploying, and we're doing all that to our contract. And I also told you guys about declaring versus deploying. And we'll be seeing all this in the next class. Are there any questions? We'll be using the tools in the next class. At least I've introduced to you guys. So please, anybody have a question? Everybody's sending me bye-bye. Any questions? So I'll be putting this on GitHub. And if you can, I want you to try implementing an ERC20 contract. And I'll share this link again, starting by example, to give you like basically like a reference to implement yours. So by next class, we'll be deploying, we'll be using all the tools we have mentioned, Starknet, DevNet, SMForge, and also SNCast. We're going to be actually using them. So thank you guys. I guess nobody has a question, so that should be all. Good night. GM, okay. I hope you guys enjoyed the class. Okay.
Yes, I did.
Thank you very much. Good night, guys.
Good night.